friends, welcome to Quick Learn tutorial series. In this video, I will explain you Arithmetic Instruction of 8051 Microcontroller. This is lecture number 15 of Microcontroller series. So let's start with the topic Arithmetic Instructions of 8051 Microcontroller. By using arithmetic instruction, here we can perform some basic arithmetic operations just like addition, subtraction, multiplication, division. Apart from this, we also perform increment, decrement operation and a special instruction that is called decimal adjust accumulator instruction. Or we know that when we perform addition, subtraction, multiplication, we require two data. So here we see that one data is stored in the. Now we know that whenever we perform any operation just like addition, subtraction, multiplication, so we require two data. So here in arithmetic operation, one data is stored in accumulator and another data is specified using any one of the addressing mode, just like immediate addressing mode, direct addressing mode, indirect addressing mode, register addressing mode, etc. So one data is in accumulator and another data is specified using any one of the addressing mode. And the second rule is accumulator is always in destination. So these are some important points we should remember in arithmetic instruction. Now the type of arithmetic instruction. In 8051 microcontroller, there are basically 24 different instructions come under the category of arithmetic instruction. First is addition instruction, second subtraction instruction, next division, next multiplication, next increment, next decrement, and last is decimal adjust. So these are the different type of arithmetic instructions in 8051 microcontroller. So one by one I will explain all the instruction with the help of example. Now some other important point which is related to arithmetic instruction, and these point we should be remember. First point is in 8051 microcontroller there are 24 different instructions under the arithmetic group. In total there are 64 opcodes. Whenever we perform any arithmetic instruction just like addition, addition with carry, subtraction, subtraction with borrow, the sum of the flag bit of PSW flag register is affected based on the result of these instructions. The multiplication and division instruction clear the carry flag and also does not affect the auxiliary carry flag of PSW flag register. After execution of multiplication, the overflow flag will be 1 when the result is greater than FFH, otherwise it is 0. Similarly, in case of division, after division operation, overflow flag is 1 or set when the content of B register is 00H before division, otherwise it is 0. The last point is the decimal adjust accumulator, that is DAA instruction, affect the carry flag only. So these are some important points related to arithmetic instruction. Now first instruction is addition instruction. In addition instruction there are two type of instruction. First is ADD, that is addition instruction, and second is addition with carry instruction, that is called ADDC. So in case of addition instruction, that is ADD, 8-bit addition between the accumulator and the second operand will be performed and the result is always stored in the accumulator register. And after the operation, carry flag, auxiliary carry flag and parity flag is affected. So these are important point of addition instruction. Next is ADDC, addition with carry instruction. This is same as addition instruction, only carry is there. So in case of ADDC instruction, 8-bit addition between the accumulator, content and second operand and the previous value of carry flag is performed. This type of instruction is useful for 16-bit operation in 2 steps. And after the addition operation, carry flag, auxiliary carry flag, parity flag is affected. Now first is addition instruction. The opcode of addition is ADD. So here this is the syntax of the addition instruction. ADD A comma source. This instruction tells that the content of source is added with the content of accumulator register and the result is stored in the accumulator register. Here we see this instruction tells that the content of source is added with the content of accumulator register and result is stored in the accumulator register. Now the example of addition instruction is, first example is ADD A comma hash data. Hash data represent it is an immediate data. So this instruction is the example of immediate addressing mode. This instruction tells that add this immediate data with the content of accumulator register and result is stored in the accumulator register. Here we see add this immediate data with the content of accumulator register and result is stored in the accumulator register. So when we perform addition, subtraction, multiplication, we required here two data. One data is stored in accumulator and another data is specifying using any one of the addressing mode. So in this instruction we use immediate addressing mode, or in immediate addressing mode, immediate data is mentioned in the instruction itself. So this is immediate data is added with the content of accumulator and result is stored in the accumulator. So when we perform this addition, first we load a data into the accumulator register. So for loading data into the accumulator register, we use this instruction move A comma hash 4. This instruction tells that move this immediate data or copy this immediate data into the accumulator register. After execution of this instruction, accumulator register contains the value 4. So when this instruction is executing, A contains 4, immediate data is 3. So we can say that 3 plus 4 equal to 7 and result is stored in the accumulator register. So 7 is stored in the accumulator register. Next example is add A comma hash 0B add. This is also the example of addition instruction and immediate addressing mode. This instruction tells that this immediate data is added with the content of accumulator register and result is stored in the accumulator register. Here I explain the whole solution of the instruction. First we want to load accumulator with a particular value. So we use this instruction move A comma hash 0F5H. This instruction tells that this immediate data is copied into the accumulator register. When this instruction is executed, accumulator contains F5H data. Now the instruction is add A comma hash 0BH. So this instruction tells that add this immediate data with the content of accumulator. So the content of accumulator is F5 and the immediate data is 0B and the result is stored in the accumulator register. So how we perform this addition? So to perform this addition, here I explain. First we convert this hexadecimal number into binary form. So first we convert F5 into binary. So this is the binary conversion of F5 and then we convert 0B into binary. So this is the conversion of 0B. Now we perform addition. Before you adding any binary number, we must know about the rule of binary addition. And I assume you know the rule of binary addition because in first year we already learned the binary addition. So I will assume you know binary addition. So in case of binary addition, 1 plus 1 equal to 0 with carry 1. Carry is here. Now 1 plus 1 again equal to 0 with carry 1. So answer is 0 and carry is here. Now this one and this one. 1 plus 1 again 0 with carry 1. Next 1 plus 1 again 0 with carry 1. Next 1 this carry 1 and 1. Next when we add this 1 and 1 in binary, the result is 0 with carry 1. Now next 1 plus 1 0 with carry 1. Again this 1 plus 1, 0 with carry 1. Last is 1 plus 1, again result 0 with carry 1. So here when we perform this addition, the result is 0, 0, 0, 0, 0, 0, 0, 0. It means the whole data is 0 and 1 carry is generated. So this result is stored into the accumulator register. Now after the addition, register A contain value 00H and flag are affected. Which flag are affected? Here carry is generated. So the carry flag bit of PSW flag register is affected and set 1 because there is a carry out from D7 bit. Next is parity flag. In this result there is no 1. So parity flag bit is 0 because the number of 1 is 0. Next flag bit is auxiliary carry flag. Auxiliary carry flag is set to be 1 because there is a carry from D3 to D4 bit. Here when we perform this operation 1 plus 1 0. So carry is generated here in the D4 bit. That is why auxiliary carry flag is set. So hope you understand the whole operation. Now some other example of add instruction using different addressing mode. So the first instruction is add ADD A, 40H. In this instruction, 40H is a particular memory location where data is stored. So this instruction tells that add the content of 40H memory location with the content of accumulator register and result stored in the accumulator register. So here I write add the content of 40H memory location with the content of accumulator register and result stored in the accumulator register. So this is the example of direct addressing mode because in this instruction we directly give the address where data is stored. Next instruction is add A, @R1. This instruction is the example of indirect addressing mode because @R1 is given. This instruction tells that data is stored in a particular memory location whose address is given in R1 register. So that data add with the content of accumulator register and result is stored in the accumulator register. Here I write data in memory location whose address is given in R1 register added with the content of accumulator register and result is stored in the accumulator register. Because in case of addition, multiplication, division, whatever instruction, destination location is always accumulator. Next instruction is ADDR. This instruction is also valid. Here destination is not defined because by default destination is accumulator register. So this instruction tells that add the content of R register with the accumulator register content and the result is stored in the accumulator register. So here I write add the content of accumulator register with the data in R register and result is stored in the accumulator register. Next type of addition instruction is ADDC, that is addition with carry instruction. In this instruction we add carry also. So this type of instruction is also support all type of addressing mode. So these are the some example of ADDC instruction, that is add with carry instruction. First is the example of immediate addressing mode because immediate data is given in the instruction itself. So this instruction tells that add this immediate data. Here I write immediate data with the content of accumulator and if any carry is there, so carry is also added and the result is stored in the accumulator register. Next instruction is ADDC A, R3. This is the example of register addressing mode because the register where data is stored is given here in the instruction. So this instruction tells that add the content of R3 register with the content of accumulator register and carry is also added and after the addition the result is stored in the accumulator register. Next instruction is ADDC A, data. This instruction tells that this data is added with the content of accumulator, carry is also added and result is stored in the accumulator register. Next is ADDC A, @R6. This is the example of indirect addressing mode. This instruction tells that data which is present in a particular memory location whose address is given in R6 register added with the content of accumulator register, and if carry is also there, so carry is also added and the result stored in the accumulator register. So these are the examples of addition instruction. Now the next instruction is subtraction instruction. This is the code of subtraction instruction, SUBB. In case of 8051 microcontroller, subtract with borrow and the simple subtraction, both opcode is same, that is SUBB. So the syntax of this instruction is SUBB destination comma source. This instruction tells that subtract the destination with the source and the result stored in the destination. As we know, in case of addition, subtraction, the destination is always accumulator register. So here by default the destination is accumulator register. So first instruction is the simple subtraction instruction when there is no borrow. So the syntax of the instruction is given here. Subtract SUBB a comma source. This instruction tells that subtract the content of accumulator register with the source content and the result stored in the accumulator register. The next instruction is subtraction with borrow. So first we know about why we required subtraction with borrow instruction. So answer is when we subtract a smaller number to the larger number, so we required borrow, and the flag bit of PSW flag register is affected depend upon the result. So again question is arise, we have a borrow flag in 8051 microcontroller. So the answer is no, there is no borrow flag in 8051 microcontroller. But when we perform subtraction or in case of subtraction instruction, the carry flag is treated as a borrow flag. So here subtraction with borrow instruction, the syntax is same with the previous instruction, SUBB a comma source. Here we use SUBB opcode for both subtraction with borrow and subtraction with no borrow. So this instruction tells that subtract the content of accumulator with the source and carry is also subtracted. Carry means borrow here. So borrow is also subtracted and the result is stored in the accumulator register. So after the operation, which flag is affected? So there is two conditions. First condition is if destination data is greater than source data, then the result is positive, there is no borrow, so the carry flag bit of PSW flag register is set to be 0. Next condition is if the destination data is smaller than source data, then the result is negative, there is a borrow generated here, so the carry flag bit of PSW flag register is set to be 1. So these are the condition of subtraction instruction. Now some point to be remembered in case of subtraction operation. In case of 8051 subtraction, we use carry flag as a borrow flag. There is no borrow flag in 8051. So here for borrow we use carry flag. Next is subtract with borrow is required when we subtract a smaller number to the larger number. Subtract with borrow is required only when we subtract a smaller number to the larger number, so we required borrow flag. And in both cases, with borrow or without borrow, the syntax is same. In case of 8051 subtraction is performed by using 2's complement addition method. So the procedure of subtraction is first we take second complement of the source data and that particular result of second complement of source data is added with the destination data and the result of addition is stored in the destination, and according to that result some flag of PSW flag register is affected. Which flag is affected? If destination data is greater than source data, result is positive, we do not require any borrow. So the carry flag bit of PSW flag register is 0. Next condition is if the destination data is smaller than source data, then result is negative, borrow is generated, and when borrow is generated, the PSW flag register carry flag bit is 1. So these points should be remembered in case of subtraction operation. Now example of subtraction instruction. Here subtraction instruction is given with the help of different addressing modes. So the first example is SUBB A comma hash data. This instruction is an example of immediate addressing mode because immediate data is given in the instruction itself. So this instruction tells that subtract the content of accumulator with data given in the instruction and the result stored in the accumulator register. So if we want to solve this instruction, first we load accumulator with some content. So to load accumulator with some value or content, we use move instruction, move a comma hash 4. This instruction tells that move this immediate data into the accumulator register. So when this instruction is executed, the accumulator register is loaded with value 4. Now the subtraction instruction SUBB A comma hash 3. Here accumulator contain the value 4 and hash 3 and this is 3 is the immediate data. So this instruction tells that accumulator contain that is 4 minus 3. The result is stored in the accumulator register. Next instruction is SUBB A comma RN. This instruction is the example of register addressing mode. This instruction tells that subtract the content of accumulator with the content of RN register and result is stored in the accumulator register. Next instruction is SUBB A comma @RI. This instruction is the example of indirect addressing mode because the indirect address of the data is given here. This instruction tells that the content of accumulator register is subtract from the content of the memory location whose address given in the RI register and result is stored in the accumulator register. Next instruction is SUBB A comma direct. This instruction is the example of direct addressing mode. This instruction tells that subtract the content of accumulator with the data whose address is given here and result is stored in the accumulator register. So these are some example of subtraction instruction. Now next is multiplication instruction. The opcode for multiplication is MUL and the syntax of this instruction is MULAB. MUL is the opcode of the instruction. This instruction is different from other instruction because in this instruction the two data is not separated by comma. Here we write direct A, B without comma. A is the accumulator register. So first data we load in the accumulator register and B is the B register. Here we load second data into the B register. So in case of both multiplication and division instruction, we should use only accumulator register and B register. We do not use other working register like R0, R1, R2 up to R7 or RI register. We only use accumulator register and second operand is stored in the B register only. Or this instruction tells that multiply the accumulator data with the data stored in B register and the result is stored in A and B register both. How we store result in both A and B register? So here the number in A or B register is multiplied, then put the lower order byte of the result in accumulator register and the higher order byte of result in B register. The overflow flag bit is set to be 1 if product is greater than FFH. And the carry flag bit is 0 all the time in case of multiplication and division instruction. So we can say that in case of multiplication or division instruction, no flag is affected, only overflow flag get affected. And overflow flag is set when result is greater than FFH. So this is the example of multiplication instruction. MULAB. MUL is the opcode, AB is the operand. So Here A is the accumulator register where one data is stored and second data is stored in the B register. So first we load data in A register and data in B register. So to load data in accumulator register and B register, we use move instruction. Move A comma hash 95H. This instruction tells that this immediate data is copied into the accumulator register. Or after the execution of this instruction, accumulator register is loaded with 95H data. Next, move B comma hash 10H. This instruction tells that this data is loaded or copied into the B register. When this instruction is executed, B register is loaded with 10H value. So when this instruction is executed, mul AB, we perform multiplication and the result of multiplication is 0E99H. So 99H is the lower byte of the result and 0E is the higher byte of the result. So I have already told the lower byte of the result is stored in accumulator register and the higher byte of the result is stored in the B register. So the result is stored in accumulator register is stored 99H. This is the lower byte of the result and B register is stored 0EH. This is the higher byte of the result. So in this way we perform multiplication operation. Next is division instruction. The opcode of division instruction is DIV. This division instruction support byte by byte division operation only. So the syntax of division instruction is DIV AB. Here also we not use any comma, we directly written AB. A is the accumulator register. So one operand present in accumulator register and B is the B register. So second operand present in the B register. When we perform division, the result is remainder and quotient is generated. So remainder is stored in the B register and quotient always is stored in the accumulator register. This is the instruction. First we load data into the accumulator and B register by using these move instructions. When the data loaded in A or B register, we perform division operation. After division, some quotient and remainder will be generated. So quotient is stored into the accumulator register and remainder is stored in the B register. And so which flag bit is affected? In case of multiplication or division instruction, carry flag bit is 0 at all the time. Next instruction is increment instruction. The opcode of increment is INC. This instruction increment the specific operand by 1 and in this instruction no flag bit are affected. So first we know the meaning of increment instruction. In this type of instruction, it is not a addition. It is just count the next number. It means this instruction nor increment any number. It is only going to count the next number. Increment count the next number or decrement count the previous number. So in this case, no flag are affected by this instruction. All the type of addressing mode. So first instruction is INCA. This instruction tells that accumulator register is incremented by 1 and result is stored in the accumulator register. Next instruction is INCRN. This is the example of register addressing mode. This instruction tells that add the content of RN register is incremented by 1 and result is stored in RN register. Next is INC30H. This is the example of direct addressing mode because direct address is given in the instruction. So this instruction tells that this memory location is incremented by 1 and result is stored in the this memory location. We do not perform addition in the content. We only increase the memory location. Next is INC@RI. This is the example of indirect addressing mode. Next instruction is INC DPTR. DPTR is a 16-bit data pointer instruction. This instruction tells that increment the data pointer instruction by 1 and result is stored in the DPTR register. Next is decrement instruction. The opcode of decrement instruction is DEC. This instruction decrement the specific operand by 1. As I have already, increment instruction is only going to count the next number, or decrement instruction is only going to count the previous number. Don't think that it is adding or decrementing the numbers or content. No flag are affected by using these instructions. So the instruction is, this type of instruction is also support all type of addressing mode. First instruction is DECA. This instruction tell that accumulator is decremented by 1 and result is stored in the accumulator register. Next instruction is this DECRN. This is the example of register addressing mode. This instruction tell that RN is decremented by 1 and result is stored in the RN register. Next is DEC30H. This is the example of direct addressing mode. This instruction tell that decrement 30H memory location by 1 and result is stored in the 30H memory location. Next instruction is DEC@RI. This is the example of indirect addressing mode. And next is DEC DPTR. Now next is decimal adjust instruction. The opcode of this instruction is DA. Decimal adjust instruction adjusts the content of the accumulator. This instruction is used to perform BCD operation, that is binary coded decimal operation, or BCD addition. The carry bit is set if the result value is greater than this number. Otherwise it is clear. So the syntax of this instruction is DAA. This instruction tells that decimal adjust accumulator instruction. So here I explain all the arithmetic instruction with the help of example. So hope you like the video. For more interesting video, keep watching and keep sharing my videos.